tutorial on mesh current method. And in this last tutorial, we are going to use the mesh current method to calculate the current I0. So I0 is the current through the 1 ohm resistor. We are going to use the mesh current to calculate its current. What you have to know is the question will tell you to use super mesh to calculate the current in the resistor. The question will tell you to use mesh current method. But you have to know that particular type of circuit is what? A super mesh circuit. So we are using the mesh current method to find what? I0. And I0 is the current going through 1 ohm resistor. So as we identify the number of meshes, then we assign our current to them. So in this diagram, we have 4 meshes. So let's assign our mesh currents. So in this mesh, I'll call it I1, I2, I3, and what? I4. So I have mesh current I1 in this mesh, I2, I3, and what? I4. Alright. So you can now see where the super mesh is occurring. The super mesh is occurring where? In these 2 meshes, because we have a current source lying between mesh 1 and mesh 2. So we treat the whole of this mesh, as what? A super mesh. Then write our KVL in it. We have another current source here, but that current source is not lying between 2 meshes. So there is no super mesh occurring here. But then we can say that our I3 is equal to what? -2 amperes. Because in this mesh, the current there is what? I3. In this direction, moving in this branch, and we have a current 2 amperes also on that branch, but that current is moving in opposite direction towards our I3. So back in our previous tutorial 3, we realized that this current I3 will be the same as what? 2 amperes, but in opposite direction. So I3 in this diagram is given as -2 amperes. Good. Then you check your 4th mesh. In this mesh, we can write KVL because we can get the voltage here, and there. So we can write our KVL here, then we write KVL in this what? Super mesh. But we are not going to write KVL here. Why? Because we have a current in that mesh, and that I3 is the same as the 2 amperes. So there is no need to write KVL here. But we write the KVL here and the super mesh. So first of all, let's write KVL in mesh 4. Let's write KVL in mesh 4. You can start from any of the elements you want. So let's start from this. We are moving in the clockwise direction. So we have -9 volts. We move to 4. The voltage drop will be plus minus. So we have a -4 times what current? I0 4. Then we come to 1. 1 is lying between what? Mesh 4 and mesh 3. So the voltage there will be what? The resistor 1 times what? The current I4 minus what? I3. Because it is lying between these 2 meshes. Then we proceed to the 2 ohms. So the 2 ohms will be -2 times the current I4 minus what? I2. Not forgetting that your 2 ohms is also lying between mesh 4 and mesh 2. So its current is what? I4 minus I2. And that is equal to 0. Don't forget to bring your equal sign equal to 0. Don't forget it's an equation. So we can now expand this. So expanding this, we have -9 minus 4 I4 minus I4 I3 2I4 plus 2I2 giving us what? 0. So from here I have 2I2, I have I3 here, I4. So we get what? -7 I4 is equal to what? We have -9 here. I'm sending it, I have +9. And I can call this one what? Equation 1. So we now have our first what? KVL equation in the mesh 4. So we are now going to write the KVL equation in what? The the super mesh. We are not writing KVL here because of this current source. So let's write KVL in super mesh. Good. So in that super mesh group, we are starting from the 24 volts now, then we go to the 4, we move to 3, we move to 1, we come to 2 and work these two because they are all part of the super mesh. So let's start from the 24. I have a positive volt 24 because I'm moving clockwise, I've entered negative and leave the positive. So positive 24. Then I come to the 4, I have minus 4 times the current I1. Then I'll proceed to this one. I have minus 3 times the current what? I2. Don't forget, I2 is the current flowing through the 3. I2 is the current flowing through what? The 1. So I have minus 1 times current what? I2. Then I'll come to 2 ohms. Now for the 2 ohms is lying between what? Mesh 2 and mesh what? 4. So 8 current is what? I2 minus I4. So I have minus 2. I2 minus what? I4. And that is the voltage across these two. Then we come to these two. These two is also lying between mesh 1 and mesh 3. So I have minus 2 multiplying what? I1 minus what? I3. And that one is equal to what? 0. Have you seen? So we started from 24, we came to the 4, we moved to this 3, we came to this 1, we came to these 2. These 2 is between I2 and I4, so I2 minus I4. Then we came to these 2, which is I1 minus I3. So let's expand this. We have 24 minus 4I1 minus 3I2 minus I2 minus 2I2 plus 2I4 minus 2I1 plus 2I3, giving us with 0. So let's group like that. So I have I1, so minus 6 I1. I have I2, which is giving us minus 6 what? I2. Then we go to I3. I have I3 here, which is plus 2 I3. Then do we have I4? Yes, we have I4. We have plus 2 what? I4. And that one is equal to what? I have 24 here, so I'm sending it to the other side. I'll get minus what? 24. So we are just simplifying the equation. We can divide through this by what? 2. So if we divide through by 2, we have minus 3I1 minus 3I2 plus I3 plus I4 is giving us minus 12 as our second equation. So we have equation 1, we have what? Equation 2. And in those two equations, how many unknowns do we have? We have 3. We have I2, I3, I4. In this one, we have I1, I2, I3, and what? I4. But don't forget, we are saying that our I3 is equal to what? Minus 2. So it means we can substitute these values into both equations. So substituting I3 into equation 1. Let's say I3 into equation 1. If we substitute that value into this equation, what do we have? We have 2I2 minus 2. We have plus I3. So I3 is negative to minus 2. Minus 7I4 is giving us what? 9. So I have 2I2 minus 7I4 giving us what? 11. As let's see our third equation. So 2I2 minus 7I4 is equal to what? I'm sending this to here. So 9 plus 2 giving us 11. In this equation, we have to substitute our I3 value. So we know I3 is what? Minus 2. So I3 into equation what? 2. So let's do our substitution. We have minus 3I1 minus 3I2 Our I3 is what? Minus 2. So I have minus what? 2 plus I4 is giving us what? Minus 12. So from here we have minus 3I1 minus 3I2 plus I4 is giving us minus 2 here will give us plus 2. So minus 12 plus 2 is giving us minus 10 as our fourth equation. Okay, so now we have these two equations. So we need to write our third equation, which is what? The KCL. So I'm going to write KCL at the junction where the super mesh occurs. So let's take the junction here and name the junction what? A. So always what you have to know is between those two currents, I1 and I2, one of them will be entering that junction and the other will be leaving. So ask yourself, between I1 and I2, which one is entering? You realize I1 is what? Entering, but then I2 is what? Leaving. You can just check, I1 is moving on this branch like this. So A direction is going this way, which is what? Entering junction A. I2 is moving in this direction. So you can see I2 is what? Leaving this junction. And this 4 is what? Entering. So our KCL at node A. KCL at node A is giving us what? I1 plus 4 equals what? I2. So let's do them. I1 minus I2 is equal to minus 4, which is what? Let's see equation 5. So we've now gotten our three equations. The next thing to do is to solve for what? Our variables, which is I1, I2, and I4. Those are the three unknown variables. So let's solve it together and get these variables. So I have 2 minus the I2 here is what? 2. I don't have I3 here. So the variables are I1, I2 and what? I4. So we don't have I1 here. So I1, the first coefficient is 0. The next variable is I2, which is 2. The next variable is I4, which is minus 7. And the right hand is 11. We come to the second equation. We have minus 3. The second variable minus 3. I4 is 1. And the right hand is minus 10. We come to here. We have I1 to be 1. I2 to be what? Minus 1. We don't have I4 here, so 0. And our right hand side is what? Minus 4. So solving this, you get to I1. So we have the I1 to be minus 0.425 amperes as our I1. We will get our I2, our second variable, to be 3.575 amperes. Then our last variable, which is I4, is what? Minus 0.55 amperes. So we've managed to get our mesh current. But the question is asking us to find what? I0. Right? It is asking us to find I0. And I0 is the current through 1. And we know that the current through 1 is what? I3 and I4, the difference between these two. But let's check something. The I1 given in the question is moving downwards. Meaning between these two currents, the one which is moving in the same direction as the I0 should be considered positive. So between I3 and I4, you realize I3 is also moving clockwise like this. And it is in the same direction as I0. So I3 is positive, but I4 is what? In the opposite direction I0. So that one will be the negative. So our I0 is equal to what? I3 minus I4. Not I4 minus I3. It is I3 minus I4. And I3 is what? Minus 2. So minus 2 minus I4 is what? Minus 0.55. So minus 0.55. Then we have our I0 really equal to what? Let's see. Okay. So we have minus 2 minus 0.55, which is giving us minus 1.4 amperes. That is what I naught. So I naught, the current flowing through what? The 1 ohm resistor is equal to minus 1.45 amperes. So this is the answer we have using the super mesh approach. Thank you very much for watching this last tutorial on mesh current.